Okay, this is probably the most important because this problem is the procedure behind some of the stuff that we've been looking at as not fake math but real math. So how do you deal with one of these recursion equations? They're just trying to get your feet wet with this problem, and this number 27 and 68 will change for you. So I have no problem sharing this with you because this is going to change for your problem. So the first thing, like, it's useful to think of anything with variables as real stuff. So break it up into new and old. So for example, if I look at this recursion formula they gave me up here, the new stuff is here and the old stuff is here. Pn is the next, Pn minus 1 is the previous. Next previous is probably better than new old. P0 is my initial condition. Second step is to make a table. This. So here, just like I did with Dr. Cottom's actual numbers, I'm just going to start listing my n first. My new is the Pn. So I start out with n equals 0, and they gave me that P0 is 68. So the 68 goes here. How do I get the next one? Well, in the next row, my old is the 68. So it's new is equal to old plus 27. So I take the 68 and add it to the 27 because that was the old plus 27, and I get 95. So P1, and I should have actually written that, P sub 1 is 95. Now I do it again, except now my old is this 95. That's my new old. So I now I always look one back at my previous row. My previous row had a 95, so that's my old. So then I put old is 95 plus 27, and I get 122. And I just keep doing this process to get the next few iterates. It's like you had a button on your calculator. You put the number 68 and you push that button, and it just keeps adding 27 over and over. In fact, that's what, if you go on Google Calculator, that's exactly what it does. Let's look at that. This might be a cool way to do it. Let's see if I can make this work. So I started out with 68, and I add 27. So if I'm just adding 27 every time, so I can just add 27, boom, I get all of them. So it's like I have a plus 27 button on the calculator and just pushing it again and again. I don't have a plus 27 button on my calculator, so I'm actually literally adding them both, plus 27. So that's all I'm doing. I'm just adding the previous junk and adding 27 to it. All right, so let's go back to this. Let's see if I have the... I don't know why it's doing this. Let's see. So then what do they want here? Well, they just want you to know that the subscript n stands for the present and n minus 1 stands for the past, or the current is equal to the past. You want to put the right subscripts here. If you have any issues with that, just send me a text so I know that that's an issue. The difference is actually something important. We talk about the differences all the time, how much something's changed. So you want to think about if you have something moving with time or moving with like clinical visits, there's going to come a time, hopefully, that you've got a set of groupies in the case of the dropout case for when we talked about the bariatric surgery case. So maybe eventually there's going to be a set of groupies that consistently comes. And I think of this for everything. I'm actually on the hunt now thinking about a research problem here, because think about people who come to the gym. We can get gym data. They come on after January 1st, and then they start to drop off. But then if you're a gym junkie, you know that there's a set of groupies that always consistently go. So you're eventually going to get no change, and this set of groupies are going to go always. So if you want to look at the change, you subtract the old from both sides. So the new minus the old will tell you how much something has changed. So initially, in the beginning of the new year, you're going to have lots of folks coming to the gym, and then new minus old is going to be pretty big, that difference, because there's a whole bunch of new folks in the gym. But then over time, by March, I know it's by March because I've asked this before, by March, you're going to start to get this change is going to drop off to 0 because you're going to get no change. Every time you go to the gym, it's the same old people there. So, so I did a subtract old from both sides, and that's what they want here. And I'm giving you the reasoning of why we care. We'd like to care when we'd like to see when that change stabilizes. So that's the change. That's what we're usually after. It's also called the difference. And I'm going to let you put in the correct subscripts here based off of my translation that new is PN and old is PN minus 1. So you can put in the right subscripts here to make this work out. And if you do have any issues with that, just send me a text.